Everybody. I'm Michelle Tennant Nicholson. I am the president of Henderson County Beekeepers Association here in beautiful Western North Carolina. And I just got back from summer conference with the North Carolina State Beekeepers Association, and really wonderful conference. And on stage, I was so excited to see all these women, all these females researching and helping beekeepers. And so I thought, gosh, wouldn't it be great to have some of them come onto the Henderson County's YouTube channel and recreate the presentation that they did for all the beekeepers in Pinehurst, North Carolina, a couple of weeks ago for you here on YouTube. And also, I thought, gosh, I'd like to just make sure that you all know about these rising stars who are helping us keep our bees and our hives healthy in our quest to make sure that pests are minimized as we harvest our honey, we grow our apiaries, and so forth. So with no further delay, let me introduce Emily Dillon. Emily, thanks so much for being with me today. Why don't you introduce yourself and tell everybody about who you are?
Yeah, Michelle, thank you so much for having me. I'm so excited to have this opportunity. Hi, everyone. My name is Emily Dillon, and I am a student at the University of Dayton in Dayton, Ohio. And this summer, I've had the absolute pleasure of working in Dr. Casey Raymond's lab alongside PhD candidate Christian Lopez Guerra this summer through NC State's Be More program. So my work this summer, it's really focused on investigating opportunistic bacteria in honeybee hosts. So this experience really allowed me to enhance my portfolio of microbiology and molecular biology skills and techniques. And it also introduced me to the practice of beekeeping, which was something I had been pretty unfamiliar with before. So it was really
Oh,
exciting
so
for me.
oh, so this summer was the very first time that you were beekeeping? Oh, that's fascinating. Well,
Yes.
fun fact is I used to live in Cincinnati, and my family's from Appalachian, Ohio. So I'm really familiar with the University of Dayton. And we're the Be More program, everybody, is under Dr. Tarpey and
Mhm.
the endowment. If you're interested in learning more about what North Carolina is doing to support its beekeepers, which is pretty remarkable, just go to ncbeekeepers.org, NC as in North Carolina. And then you'll find out, click over to where it says the endowment, which that whole program funds and supports things like the Be More program. So we are so excited. Okay, I'm really interested in the bacteria. Is it any way related to a Netflix special that I saw recently about hacking my gut microbiome? Is it like that?
I mean, we do study the bee gut microbiome. So a little bit, like we kind of almost like manipulate how we want their gut microbiome to look. So like we collect a lot of our bees germ free, but I don't know how much. I haven't seen that Netflix show, so
Okay,
I
okay.
don't know how much it relates.
Okay, well let's get to your PowerPoint presentation,
Okay.
and then sprinkle in little things that you've experienced about being a new beekeeper, because I think people would probably find that really funny. So go ahead.
Yes. All right. So I wanted to start out by explaining what exactly an opportunistic bacteria is, because before this project I wasn't super familiar with that. Um, but in order to explain like this research project, it's a crucial fundamental part of what I was doing. So we shorthand opportunistic bacteria because that's kind of a mouthful to OBs, and they are important microbes that can infect and cause disease within susceptible hosts. So, unlike obligate pathogens, host transmission is not a necessary survival mechanism for opportunistic bacteria. So then the question arises is why would they use transmission, infecting a host and causing disease or harm when it isn't necessarily essential for their survival?
Okay, well hold on. Okay, so let's back up for just a second, because I'm a nerd and I have a master's degree in human development, right? So I love everything that you just said and I got it, but let's back it up for the like my uncles in Appalachia, Ohio. I'm a second generation beekeeper, and they'd be like, say what? Okay. So
Yeah.
basically what you're talking about with opportunistic bacteria is buggies that are sort of like what we see a tick on a dog, right?
Mhm.
So a tick on a dog, that's an opportunistic bug on a dog, right? Sort of like that.
Yeah, sort of like
Okay.
that.
And then the other one that you said was, what was the other word that you said?
An obligate pathogen.
What's that? What's an obligate pathogen? That you lost me.
So I think that an obligate pathogen, to explain it, like the tick on the dog, if you have a tick on a dog that like doesn't bite into the dog and hurt the dog, that's like an opportunistic. It doesn't have to bite the dog, but it could.
Okay,
And then the obligate one would be like the tick has to bite the dog immediately or else the tick dies.
clear. Okay, let's move on. Okay, okay,
Okay.
perfect.
Perfect. Okay. And then in order to test why an opportunistic bacteria would develop the mechanism, the like biting into the dog mechanism that could harm a host, in our case, our host was a honeybee, I was able to conduct a bunch of series of investigations and it started with evolution. So here is a really pretty picture of my opportunistic bacteria, which is Serratia marcescens, which I believe is a pretty common one in beekeeping from what I've been told. Um, and it's in red or like the kind of like pinkish color, and it's engulfed by a predator, and it's a protozoa predator in this case. So that's one of the ones that I studied. Um, and experimental evolution was really key because we would grow up predators, we would grow them alone or alongside a predator to see how they would react when they came in contact with a host, like a honeybee. And they were evolved for 180 days, which is a lot of time. This is only like a 10-week program for the summer. So obviously this part of the project was done by my mentor, Christian, before I got there. But yeah, and I think I said it here. We conducted the evolution in vitro and in honeybee hosts, and then we would investigate the factors that would lead to the development of more defensive traits that could then potentially cause disease in honeybees.
Great. Okay. I'm with you.
Okay,
Beekeeping. That we
great.
know this slide, right, everybody?
Yes.
This slide we get, right? Don't worry, hang in there.
Yes. So maintaining proper hive health was super important for the project, given that the honeybees are the ideal host organism for us. So that's kind of where my experience, my new experience came in, was doing like a lot of the hive checks and treating for mites and checking for beetles. And again, it was my first ever experience beekeeping. So I was so lucky to have such amazing mentors who would walk us through the project and like help us look at the frames and be like, what are you seeing on this side of the frame? What are you seeing on this side? And like helping mark the queens. And it was just such a cool experience. I was so glad that this was part of our project and that the honeybees were a good host for this research.
I love it. One of my personal commitments is that more women be exposed to beekeeping. Because as a child, I was not allowed to go into the hives because I was female, right? My uncles were trying to protect me. I'm the only one that ended up being a beekeeper. So I love that you learned all that in while you're doing your research. It's really great. And we hate hive beetles. Okay. So
Yeah.
any of us who've lost hives to hive beetles, please tell us more. What did you find
One
out?
one of our hives had like a couple beetles, and so we named it Beetlejuice as a hive because it didn't have a bunch of names. And so I learned about the practice of naming your hives, which some people do, which
Yeah.
I think is very funny, but I
Yeah.
liked that.
There's a book and a movie and an old folklore about talking to the bees. It comes out of Europe, and so I highly recommend that if you're not familiar with that folklore, that you check it out. In short, we do have a relationship with our bees. A lot of beekeepers just go out and talk to the bees, like we do our dogs. So go on.
Yeah, one of the girls from you said that you were happy about female beekeepers and like getting exposed to that. One of the girls in our program who works in Dr. Raymond's lab with me, she goes to school in Ohio as well, Kenyon College, but she is an experienced beekeeper and like those were her pets growing up. So it was really cool to have like a female like mentor who's also my age kind of explaining things to me while I was doing it too. So that was
Yeah,
also
our
a
vice
really awesome
president,
experience.
the vice president of our club is 18. So
Wow,
yeah.
that's amazing.
Yeah, she's been doing keeping bees for 7 years now. So it's we're
Wow,
really very committed that young people take this up.
that's awesome.
Great. Okay, what else,
We'll keep
Emily?
going. Yeah. So in order to maintain the purity of the gut microbiome of the honeybees, we were collecting them germ-free so that less variables would impact our study of opportunistic bacteria. And bees were a great host to use because you are able to use large populations and kind of arrange that experiment the way you want with a large group of bees. So that was really interesting for me, collecting so many to work with. But that was a cool experience. And then finally, I conducted numerous tests and I analyzed our opportunistic bacteria to understand how the pressure that would be applied by a predator when it was evolved with it would impact the way that it has adapted
The
after
way
evolution.
that the predator has adapted or the bee has adapted.
Well, it would be the bacteria
Okay.
itself, and then the bacteria's adaptations would then affect the bee
Yeah. Okay.
because we have our like experimental model is like bacteria goes here, and then we have the bacteria existing in media, so like an outside environment with a predator and without, and then after it's done existing over here, it exists in the bee.
Mm, mhm,
Mhm. So then we introduce that new evolved bacteria to the bee, and we
mm,
see what kind of traits have developed. So it could be like there's a good example is biofilm formation in the bacteria. So when our bacteria was evolved with a predator, we saw like a significant increase of biofilm production, which
mm.
is like a more defensive trait. So when introduced to a bee, you would say that it would harm the bee more. You could assume it might harm it more. And like one of our experiments that we did was seeing the mortality rates of bees when introduced with the different strains of bacteria that we were testing. Um, and we need to repeat that one a little bit more just because it's a pretty intensive test. So that's something that they want to look into more is seeing the mortality rates of the bees when introduced with various um, bacteria strains. So that was something interesting that we've done. And
Great.
like, even though I've worked on this project for 10 weeks, this has been almost like a 4-year project with my mentor. So there's still a lot of work to be done for him. But I was really happy that I got to be involved in a significant portion of it for this.
Yeah, we're excited to see what happens next from his research.
Yeah. So I say that the phenotypic and genotypic analysis were conducted. And by that, I mean that I studied the mutations, the DNA, the expressed genes, the morphology, behavior, mortality rate, like I mentioned. I studied growth rate. I don't know if I mentioned that, but I studied the growth rate and other defense mechanisms to further my understanding of how these opportunistic bacteria are evolving in different environments. And then these analyses, they addressed our physical, physically observable traits of our opportunistic bacteria, and as well as the like more genomic or the DNA component of our bacteria.
Mm.
So those were the like big components of study that I focused on, which seems like a lot, but it wasn't it wasn't too bad if you break it down into so many weeks.
Yeah, 10 weeks, you became a new beekeeper and you did all this research.
Yes, I know.
I think you had a
I
great
know.
summer. Yeah.
It was
This
great.
gives you
It
show
was
you what you
great.
can get done in 10 weeks, right?
Yeah. Yes. But I think it's important to talk about why beekeepers especially should care about this project. But in a medical sense, opportunistic bacterias, they've demonstrated pretty significant negative impacts on urinary and respiratory systems within susceptible hosts. So this could be like an immunocompromised host. And my bacteria, Serratia marcescens specifically, has proven in multiple studies that they have impacted urinary and respiratory systems. So that's something important medically to investigate a little bit further. And environmentally, understanding how opportunistic bacteria like Serratia marcescens will respond when put into new environments or even like a natural system. Natural systems are really complex. So when you have different like stresses and pressures in an environment is what we're trying to replicate. So having that even though we can't necessarily create a natural system because of how complex they are, having a little bit more knowledge on what it might be like when a bacteria is stressed and how if it comes in contact into a host like a honeybee, how that could impact a hive health or how could it impact a honeybee itself is like really important in understanding. So we're trying to understand a little bit more of how these types of bacteria will respond with negative pressures, and hopefully we can have a greater understanding of how it'll impact hive health. Another pressure that one of the other groups in our lab was focusing on was antibiotics.
Mm.
And so we're kind of studying the bacteria's like availability ability to evolve and adapt and like leading to more harmful traits that can impact the host. So I thought it was really interesting that they would do antibiotics because that's another commonly used um
Right. I mean,
treatment.
yeah, I mean, I know you're a new beekeeper, but these are the things that and when like when my uncles were still alive, it was pretty easy. You kept the bees or you made honey. You harvested honey, that was it. Now today we have so many more pests than what they had to deal with, 20, 30 years ago. So awesome. What else did you learn?
Oh, I was thinking about antibiotics, but one of the girls in our project, she's been doing storage of antibiotics of like oxytetracycline and how like different storage conditions and the effectiveness of the antibiotic. So I thought that was very, very cool project.
And this is
So
also everybody, that's a common antibiotic that's prescribed also to humans. Am I right?
mhm,
Yeah.
I
So
believe
what
so.
did
Yeah.
I remember I've seen that on some of the antibiotics that I've been right now. What is where was it stored primarily in the body of the bee?
The antibiotics
Yeah,
that we're testing? I
yeah.
don't know. I don't know if they actually injected the bees yet, but I know that they were testing the light sensitivity of it. So they would take the antibiotic and they would store it in like tubes and they would like vary the location around. So like in room temperature, in cold temperature where it's actually supposed to be stored at, they did it like in direct sunlight or in sunlight but covered. So they
Hmm.
would like wrap it so it would be less exposed to sun versus like a direct exposure.
Oh, so they
So
were
that was a
testing
really
it.
interesting
Yeah,
project
they
as
were
well.
testing the environment and how it actually supports
Yeah.
or
Yeah.
harms the medicine. Got you. Okay.
Mhm.
Fascinating,
Yes.
Emily.
It was fascinating. Very. It's cool to like be able to learn about other projects even though it's not mine because I'm around it all the time. So that was something really cool about this experience as well.
So do you have another slide or are we at the end of the slide?
I have one more. It's
Perfect.
just about future studies. So asking
Okay.
where do we go from here? So more work is being done to investigate more than one pressure on our opportunistic bacteria. So dual predation, it raises an interesting question where the predators now have competition with one another, not just the bacteria, or yeah, not just the bacteria, it's both predators with themselves, as well as one another with the bacteria. So, more thorough studies will be conducted in the future to create a better understanding of why opportunistic bacteria will act the way that they do in potentially harming and infecting a host. So, my
So
mentor is actually studying dual predation right now. So, that's like kind of towards the end of his project. So, he should hopefully have a few conclusions about that soon.
So what I heard you say in beak language is that the studies might actually shed light into what happens for the hives when you might have a beetle and a varroa mite both in the same hive, and like how do we, when we have multiple predators in the hive, how do we keep the honeybees healthy in their immune system? And as we all know, the while we can put all these medicines in our hives, the best way to combat any type of parasite, bacteria, um, predator that's inside the hive is a healthy hive. The fastidious nature of bees is the best way to actually keep your hives healthy. So really, so will that be coming out of the University of Dayton, Emily? Is that where you're, or is that where is that study going to, that research coming from in the future?
It'll be North Carolina. It'll be North Carolina State University.
North Carolina State University. Great.
Yes.
Okay. And then how about you? Do you think you'll be a beekeeper ongoingly, or what's the future for you?
Sure, yeah, but I'm going into my senior year. I'm a biochemistry major at the University of Dayton, like I said, and I have worked in a couple various different locations over my college career. So I've had the experience of working in like in an organic chemistry lab, a more of an evolutionary biology lab, and then I've had this experience, which I have absolutely loved, and I have loved beekeeping so much that I'm probably going to take a class at school in the spring semester with my friends to kind of show them like how amazing beekeeping is. And I'm I'm probably going to apply to grad school here, so I'm really excited. And I'm having my fingers crossed that hopefully my project will involve some bees because I think they're super important to the environment. And that was just one thing I've learned that we can't really control what kind of stressors and pressures have been happening can happen to the bees, but it's important to know what happens when they do occur to try to maintain that proper hive health because the bees are just so important. And I've really grown a great appreciation for bees over the summer.
Yeah, I don't really think that people always understand how connected the bees are to our favorite fruits and vegetables until you actually have a conversation of like, well, how impactful it really is. And, just like our human bodies, nothing replaces our strong immune system. And so we're always, as beekeepers, always looking to see like, well, how can I empower my bees to be the healthiest they can be? Well, thank you so much. And if somebody wanted to reach out and find you, how would they do that on the internet? What's the best way to reach out to you? Is like LinkedIn or Instagram, or like what's your favorite way?
We do have a LinkedIn, but I can honestly tell you I don't know my link off the top of my head. So if like you wanted to shoot me an email or something, feel free to do that. My email is my name, Emily Dillon, and then 2003 at gmail.com.
Awesome. And then you're also welcome to email me, everybody, and president at hcbeekeepers.org. And that's Henderson County Beekeepers.org. And just thank you so much, Emily. We wish you the best. Thanks for being with me today.
Yeah, thank you so much for your time and for your like your help with this whole experience. It's been great, and thank you for the positive feedback on the Beekeepers Association meeting. That was a great experience that Dr. Tarpey set up for us, and we've been very happy with the positive feedback that we've gotten on our projects because we've all worked very hard on them.
Yeah, well, good. And we should laud this. I mean, a lot of the bee clubs throughout North Carolina are fundraising for the endowment, and it's something that we are really passionate about. And having, North Carolina is a leader in the country about how we support our beekeepers. And so we're very, very committed to especially supporting research that helps us, across the world. So
Yeah.
thanks again.
Yeah, thank you so much for your time.